Hi everyone! The paper I'd like to share with you today is titled Privacy Aware Recommender System Challenge on Twitter Home Timeline. The authors are researchers from Twitter and affiliated universities, and they released a dataset with 160 million tweets along with user engagement information. They have also kicked off a challenge to build the best performing predictor of user engagement based on their dataset. That's great in itself because it gives us an opportunity to experiment with a new large-scale dataset. But the aspect that I have found the most interesting are the steps they have taken to make the dataset, as they call it, privacy aware. So how they are open sourcing their dataset while still staying compliant with the privacy laws and Twitter's own privacy policy. First, let me give a quick overview of what the dataset looks like. The dataset contains two sets of features: tweet features and engagement features. The tweet features contain information such as the tweet's text, the hashtags used, and the author's language. The engagement features let us know if a user liked, retweeted, or commented on a post, and if so, what was the timestamp of those events. Now, let's see how the dataset got actually created in a privacy-aware fashion. The positive examples are the tweets the user engaged with. The authors created these using exclusively publicly available information. So these are the tweets, comments, and likes that you would be able to see anywhere on twitter.com. For example, my likes from yesterday are publicly available, so theoretically they could be used in that dataset. The negative examples are a little more difficult to deal with if we want to avoid data leakage, because true negative samples would be the content that was presented to you as Twitter user, but you didn't choose to interact with and just scrolled away. And that information is available to Twitter, but you never agreed to make it public. So their solution is to create so-called pseudo-negative samples. How they do that is they sample the tweets that the user could have seen at the time, then they remove positive samples, and then sample randomly from the remaining tweets. Another interesting issue that the authors had to tackle is what happens to a user post that at first got included in the dataset, but at a later time the user decided to either delete the post, or made the post private, or perhaps deleted their entire Twitter account. Normally, there was no way for such a user to opt out from participating in the dataset. Even if they deleted a post and it was no longer available on the social media platform, it was still permanently frozen in the dataset. Such a situation does not comply with the most recent privacy laws, such as GDPR in the EU or CCPA in the state of California. What is novel in this work is that the authors are able to comply with these regulations by continuously updating the content and removing the posts that are no longer public from the dataset. It also creates an interesting situation in which we have a dataset that is slowly shrinking over time. I thought this paper was really interesting because it's the first time I see such a large-scale user dataset being released while still complying to the privacy laws. In the past, I have seen these privacy regulations being used as a reason to not open source the dataset in several papers from large tech companies. I think that harms the quality and reproducibility of the research that they do, and it's really great to see researchers from Twitter show that it is still perfectly possible to open source these datasets, but simply requires some extra engineering. Hopefully that will set an example for other companies in the industry for the future.